Hi guys, welcome back. What if I told you your brain may already be aging, even though you're only 25 years old? Not someday, not eventually, right now, while you're watching this video. In the next few minutes, you're going to discover exactly when brain aging actually begins. The biggest myth almost everyone believes about it. The hidden daily habits quietly accelerating it without you noticing, the surprising habits scientifically proven to protect and even partially reverse it. And one discovery near the end that almost nobody talks about, a discovery that completely changes how you should think about your own future. Let's get into it. In 2014, researchers at Simon Fraser University did something unusual. Instead of studying elderly patients in a controlled lab setting, they analyzed real-time reaction speed from over 3,000 people, aged 16 to 44, while they played a fast-paced real-time strategy video game. The result was published in the journal PLOS1 in a paper literally titled Over the Hill at 24, and it shocked even the researchers themselves. Self-initiated reaction speed, the raw cognitive motor processing that lets you react instantly to a changing situation, began declining at exactly age 24, not 40, not 60, 24 years old. And here's what almost nobody knows about this study. The decline showed up even in the most skilled, most experienced players in the data set. Expertise didn't protect them. The researchers specifically tested whether skill could compensate for the decline, and it couldn't. The slowdown was happening underneath their skill level, completely independent of how good they were at the game. For every 15 years that passed after age 24, processing speed dropped by roughly 15%. That's a real, measurable, scientifically documented decline, starting in what most of us consider the prime of our lives. But here's where most people get this completely wrong. Most people hear brain aging starts at 24 and panic, picturing their brain falling apart while they're still in their 20s. That's not remotely what's happening, and understanding the actual mechanism is where this gets genuinely interesting. Here's the part almost no headline ever explains. Your brain doesn't age as one single unified thing. It's made up of multiple cognitive systems, and they age on completely different timelines. Fluid intelligence, your raw processing speed, working memory, and reasoning speed actually peaks early. Processing speed and spatial reasoning peak between ages 20 and 24. Working memory peaks slightly later, around 25 to 29. After that, fluid intelligence begins a slow, gradual decline. But crystallized intelligence, your accumulated knowledge, vocabulary, and verbal comprehension, keeps climbing the entire time. It doesn't peak until somewhere between your mid-40s and mid-50s, and remarkably, it remains stable well into your 70s, only declining noticeably around age 80. So yes, your brain's raw processing speed genuinely begins slowing in your 20s. That part is real, and it's backed by solid evidence. But your brain's depth of knowledge, your vocabulary, your accumulated wisdom, that keeps expanding for literally decades after that early decline begins. This is the piece almost no viral headline ever includes, and it completely changes how you should feel about this whole topic. So what is physically happening inside your skull starting in your 20s? Researchers point to a few specific, measurable changes. First, cortical density. The outer ridge surface of your brain, the cortex, gradually thins over time as the number of synaptic connections between neurons slowly declines. Fewer connections can mean slightly slower information processing. Second, myelin. This is the fatty insulating sheath wrapped around your neurons that allows electrical signals to travel quickly between brain regions. As myelin gradually shrinks with age, signal transmission slows down, similar to a fiber optic cable slowly losing its protective coating and becoming less efficient at carrying information. Third, and this genuinely surprises most people, strategic memory, the specific ability to quickly recall names and numbers, has been shown to begin softening as early as age 20. That's actually why you might forget someone's name seconds after being introduced, even though you remember their face perfectly and could pick them out of a crowd instantly. These are two completely separate memory systems in your brain. and they don't age at the same rate. Now here's where this gets personal. Because what you do every single day either quietly speeds this entire process up or meaningfully slows it down. Chronic sleep deprivation is the single most damaging accelerant most people don't take seriously enough. During deep sleep specifically, your brain activates something called the glymphatic system, essentially a dedicated waste clearance network that flushes metabolic toxins out of brain tissue, including a protein called beta amyloid, which is directly and repeatedly linked to accelerated cognitive decline and Alzheimer's risk in the research. Skip consistent, quality sleep night after night, and that crucial nightly cleanup process never fully completes. The waste products simply accumulate over time. Chronically high sugar intake and diets dominated by ultra-processed food represent the second major accelerant. Persistently elevated blood sugar damages the small blood vessels that feed the brain and significantly increases systemic inflammation, and neuroinflammation specifically has emerged as one of the most consistently identified drivers of accelerated brain aging across recent research. The third major accelerant is chronic, unmanaged psychological stress. Sustained elevation of the stress hormone cortisol has been directly shown to physically shrink the hippocampus, the specific brain region most responsible for forming new memories. This isn't a theoretical concern. It's been observed and measured directly through brain imaging studies. But here's what almost nobody is talking about right now. For decades, the scientific consensus was that the adult brain was essentially fixed in place, that you were born with all the neurons and connections you would ever have, and from that point forward, it was simply a slow decline. That belief has been completely and dramatically overturned. The brain possesses something researchers call neuroplasticity, its lifelong capacity to form genuinely new neural connections in response to learning, movement, and novel experience at any age. And in 2026, MIT neuroscientists uncovered something even more remarkable that builds directly on this idea. They discovered millions of what they called silent synapses sitting dormant throughout the adult brain's cortex, making up an estimated 30% of all synaptic connections in adult cortical tissue. These are not dead, decaying connections. They're immature, inactive links that exist as a hidden reserve, sitting in wait, ready to be rapidly activated the moment you genuinely learn something new. In other words, your brain isn't simply declining in a straight line toward less capacity. It's carrying an enormous, largely untapped reserve of capacity that the overwhelming majority of people never deliberately activate across their entire lives. This single discovery genuinely reframes everything we've discussed so far. Brain aging isn't simply a one-way street of decline. It's a constant, ongoing balance between biological processes that gradually erode capacity and processes you can actively and deliberately strengthen, starting today. So given all of this, what does the actual evidence say genuinely works? Aerobic exercise is, by a significant margin, the single most well-evidenced intervention available. It measurably increases a protein called BDNF, brain-derived neurotrophic factor, which directly promotes the growth of new neurons specifically within the hippocampus. Multiple controlled studies have shown that consistent aerobic training can measurably increase hippocampal volume over time, effectively reversing a meaningful portion of age-related shrinkage in that exact region. Prioritizing 7 to 9 hours of genuinely high-quality sleep allows that glymphatic cleanup process we discussed to run to full completion night after night, clearing accumulated metabolic waste before it can compound. Deliberately learning new, genuinely cognitively demanding skills, picking up a new language, learning an instrument, taking on a complex, unfamiliar task, is one of the only documented activities shown to directly engage and activate those dormant, silent synapses we just discussed. And actively managing chronic stress through practices like meditation, consistent downtime, or simply protecting genuine recovery periods in your week has been shown in research to reduce cortisol's long-term damaging impact on hippocampal volume specifically. None of these interventions are complicated. None of them require expensive equipment or specialized clinics. They simply require genuine ongoing consistency over time. So let's return directly to the question we opened this video with. Does your brain really start aging at 24? Yes, in one specific, narrow, well-documented sense. Raw processing speed and reaction-based cognition genuinely do begin a slow, measurable decline starting around that age. But your capacity for wisdom, understanding, vocabulary, and accumulated knowledge keeps expanding for literal decades after that early decline quietly begins. And buried inside your adult brain right now, today, are millions of dormant neural connections simply waiting for you to give them a reason to activate. Brain aging was never the single fixed countdown clock that most people quietly assume it to be. It's an ongoing daily balance that you genuinely influence through what you eat, how consistently you sleep, how often you move your body, and most importantly, whether you choose to keep deliberately learning new things. The real question was never actually, when does your brain start aging? The real question is, what are you going to do starting today with the brain you currently have? If this fundamentally changed the way you think about your own mind, subscribe, because next week we're going even deeper into the neuroscience of exactly how your brain actually works. See you in the next one.